All right, I want to speak more specifically about the probe system so that if you get questions, you're able to field them on the spot. The probe, as you see, I'm turning the spindle here. The probe is driven, and it's actually not driven, it's just resting on this black nut, which is driven by the spindle. So as you see, as I turn the spindle, the nut moves, but not the probe. I'm holding the probe off of it. The probe rests on top. So what I like to do with customers is I'll often show them that the probe is just held down by the force of gravity on a rail. So it's hard to break the probe, and it's hard to break other things with the probe. You won't pierce your hand, you won't break a tube, you don't have to worry about those other things that actually, with other instruments, you should be concerned about. The other thing, like I mentioned earlier, is that the probe is held on by a magnet. So if it gets struck in the horizontal plane, it'll just snap back into location. And this, once again, is how it senses fluid. It's these two needles. Once it goes down and touches fluid, the conductance meter is triggered, and it tells the system, I am in fluid. Now, the reason we can pick up 1 microliter is because of this microsyringe back here. I mentioned this earlier, however, I want to, if you get more questions about it and you need to show them specifically, it's right here. This is the microsyringe. We use the microsyringe in combination with a pinch valve and a pressure containment system that allows us to be very, very accurate at low volumes. I don't necessarily think that you need to go into that much detail, but I want you to know that just in case, and that way you can answer questions. Now, the camera up here, the main feature for the camera is so that we can remotely log in and access and see what's going on the inside. You don't. The other feature is that the techs can see what's going on the inside of the instrument, but at the same time, the thing that we want to sell and the thing that we want to emphasize the most is our ability to remotely log in and see what's going on the inside of the instrument. Once again, the reason I like to emphasize the probe is that this is the most robust probe system I've ever seen. It's very easy to change out. It's very hard to break our probe. And even if we have to replace the probe is one of the cheapest probes I've ever seen. Most other instruments out there, the whole entire probe assembly needs to be changed if the probe breaks. So I like to emphasize the probe during demos because I believe it's a great feature. I wanted to discuss more about the microtiter plate carrier and the incubator. Just once again, this is just for if you get more questions. Don't dive too deep into this during the demo or you may lose your audience, depending on your audience. But as I said earlier, there are holes in the microtiter plate carrier. That is for the reader to go over the hole and capture how yellow the assay, the substrate in the assay has developed to be. Now, on the 4 corners of all the circles, if you were to make it a square, you'll see a gold resistor. Now that also has a hole in it. If you look very carefully, you will see a hole within that resistor. That is where the air comes up. The air is blown from a pump that's on the right side here, through this tubing, and through the manifold. Now the resistors are what heat up. The air is not hot. We do not have a heater over here blowing a hot air. It is just simply air from the room being blown through those resistors. The resistors are what heat up to the temperature that we need to make sure that the wells are heated at the temperature that they need to be heated to during the incubation step of the test. So once again, these are the resistors. They're right here. And there are 4, if you notice, there are 4 that surround every single well. And that's how we can evenly heat across an entire plate. During part of the QC process, we actually take a thermal imaging camera picture of the microtiter plate carrier to show that the heat is evenly distributed. So, like I said, I just wanted to talk a little bit more about that feature so that you see what that's about. The other thing I'll mention right here is that this is the shaker, is essentially these 2 posts, and the motor is right here. And this, where the plates sit, is an actual frame that sits on top of those posts. And that is what is shaken orbitally up to 900 RPMs. So don't be afraid taking plates on and off, and I do recommend you practice taking plates on and off. It is something that you need to get used to a few times so that you're not moving the micro-titer plate carrier when putting the plates on. All right, so now I want to discuss the reader for just a little bit more. So this is our reader. Now, once again, I said it's an LED reader. The LEDs are actually on the top, and down below here, these are the 5 detectors. So the standard reader, the standard wavelengths that they need for most assays are just 550, 630, 405, and 450. So those are the generic wavelengths that come with every single one of our readers, unless a customer specifies otherwise. But we have, I think, 5 or 6 other wavelengths that we can provide customers. But like I said, it's an LED reader, and the main key things with LEDs is that they're faster to switch on and off. They last much, much longer. You're dealing with photons, not heat and light being produced by heat. You're actually dealing with actual photons, so they need a lot less energy to be able to generate the light. So they pull less energy, they last much longer, they're more robust, and they're faster switching on and off. And that's how we can actually quickly read 2 plates well by well. Once again, there's 5 filters on every single reader. If you have a chemiluminescent system and you're demoing a chemiluminescent system, the only thing that's different in a chemiluminescent system is the reader. And in fact, the reader is not much different. It's going to look identical. The reader, the only difference is that there will be a photomultiplier tube that lowers from this top bracket and goes over the well in order to make the well dark, and then captures any of the light coming off of the well. So once again, that's the little bit more detailed explanation of the reader. The reader only moves in the X direction, while the micro-titer plate carrier will move in the Y direction, and that's how it accesses all the wells. It's essentially just a large Pac-Man that moves itself across the plate to do all the reading. I just wanted to talk a little bit more about the intelligent racks. Now, the way that we actually detect the location of the sample tube is by magnets below or on the bottom of these springs. So when a sample tube is placed in here, the spring moves, meaning the magnet moves. Below this deck are detectors that are here, here, and here. So any movement of a magnet on above them will be detected. That's how, if we scan in this barcode and then place it here, that magnet will move, and the detector will know that that sample was placed there. That is our positive identification system, and that is how it is done. There are also, these racks come in different sizes, right? But those are detected by the placement of the magnet in the front. So it's all detectors and magnets that allow us to be able to have this intelligent rack feature. And the whole tray here is just filled with detectors underneath. So once again, if you ever get asked a specific question about how that works, then you can go into that a little bit more. But once again, I avoid going too deep into that during the demo. The last thing that I wanted to mention once again is the emphasis of the 1 to 100 dilution. Many infectious disease products and other kits have dilutions that require pipetting of small volumes. That may be 1 microliter, 2 microliter, 5 microliters, 10 microliters. Most instruments cannot pick up and deliver anything lower than 10 microliters. We can't do that directly, but what we do is we make the dilution for them. So we pick up 100 microliters of diluent and 1 microliter of sample, doing a 1 to 101 dilution, and then we deliver that directly into the well. This is a huge time savings. Like I said during the initial part of this demo, the other instruments have to move diluent, move the sample, mix that, then transfer to the plate. In comparing to the Dynex instruments, we do what they take an hour to do in 15 minutes. For all diluted tests, which are there's a large number of tests out there, especially in clinical labs that require dilutions. We save a whole lot of time up front with those tests. And I just want to emphasize that feature because that is a very big selling point for our instrument. We do have a pre-dilution plate if it is required. We can dilute 1 to 30,000 if need be, but most tests don't need to go that high. But if that feature is needed, we can do that in the pre-dilution plate. But once again, 1 to 101 can be done directly into the well, and it saves